Hello everyone, this video is about experiment 4, which is the title is extraction of caffeine from tea. So first I will introduce my group mate, which is Li Wen Yao, and secondly Nur Atika Ain binti Arman, which is me, and third Sharifah Hazira Filzah binti Wan Razali. So in the video we have 6 parts, which is the first one introduction, second objective, third methodology, fourth result, after that discussion, and the last one is conclusion. The first part is introduction. First, extraction is the physical process of transferring a component or a combination of compound from one phase to the next. Water-soluble component, tea leaf or coffee bean were transferred into water, which act as solvent. Caffeine is naturally occurring chemical substance that found in tea leaf and coffee bean. Student objective was to extract caffeine from tea leaf by using a solid liquid extraction method first and followed by a liquid-liquid approach. Extraction is a process for isolating and removing a certain chemical from another substance. Liquid-liquid extraction is a fundamental operation in the organic chemistry lab that should be learned. In this experiment, a solid liquid method was used first to extract the caffeine from the tea bags to dissolve sodium carbonate in the hot water. So, for this experiment, there are two objectives. The first one is to be able to extract caffeine from tea leaf using solid liquid and liquid-liquid extraction technique. And the second one is to be able to determine the melting point of the crystal of caffeine obtained. That is methodology. There are 40 steps that we need to follow for this experiment. For the first step is two identical tea bags were weighed and their mass were recorded. Second, 30 ml of deionized water, 2 grams of NaCl sodium carbonate, and boiling chip were placed in a 150 ml beaker, and after that the beaker is then placed on hot plate at 120 degrees Celsius until it boils. After that, the boiling chips were taken out by using forceps, and the two tea bags were completely immersed into the water for 3 minutes. After that, a test tube was used to squeeze the tea bag without breaking the tea bags. Next, the hot liquid was decanted into a 50 ml helium flux, and after that 20 ml of deionized water was added to the same beaker and the content were brought to boil again. After that, the liquid was decanted in the beaker into the same helium flux, and then the tea bags were pressed with a test tube to express as much as liquid, and this liquid was transferred into 50 ml helium flux. Next, the extract was put in ice water until it become room temperature, and then the tea extract from the helium flux was transferred to 125 ml separator funnel, and then is supposed by a ring on a ring stand with clamp. After that, 5 ml of the dichloromethyl were added to the separator funnel, and the The mixture in the funnel was aggregated without shaking it vigorously. The value of the separator funnel was opened after each aggregation to remove any gas pressure. And then the content of the separator funnel was allowed to settle for a minute until two distantly clear layers were valuable. And after that, the lower layer was carefully drained into a 20 ml alum flux. And step 7 until 9 were repeated by using a second 5 ml portion of dichloromethane. And next, 0.5 gram of hydrogen sodium and hydrosodium sulfate was added to the content in 25 ml iron flux. The content of the flux was then swirled. The liquid from the flux was decanted into a 25 ml beaker using a Poster pipette. The solution was let to evaporate on the sandbath with temperature below 150 degrees Celsius. When the solution in the beaker started to become cloudy, the beaker was removed from the sandbath and it was allowed to cool at bench and from caffeine crystal. And a piece of paper was wet and it must recorded. And then the caffeine crystal from the beaker was scraped onto the paper using a metal spatula. The paper were with the crystal was wet. After that, all comparing calculating was done and recorded. Some caffeine crystals were stuck inside a melting point tube and placed inside a automatic Fisher-John melting point apparatus. The melting point was recorded.
Hello, my name is Sharifah Hazirah Filzah, and I will talk about the results that we obtained from the experiment. The mass of the two tea bags were 4.965 gram, and the mass of paper was 1.009 gram. After the extraction process, we obtained the caffeine crystals and weighed the mass. So the mass of paper and caffeine was 1.150 gram, and after subtracting it with the mass of paper, we obtain 0.141 gram of caffeine. Using the formula of mass of caffeine divided by mass of tea bags and multiply by 100%, the percent yield of caffeine per gram of tea bags was 2.84%. Lastly, at the end of the experiment, the melting point of the caffeine that we obtained was 250 degrees Celsius.
Hello, my name is Liwen Yao and I will talk about the discussion of this experiment. First of all, we obtained white glycerin needles during the end of our experiment which proven to be caffeine based on the data obtained from the National Toxicology Program. This is the picture of the caffeine that we obtained during the end of our experiment. The method that we use to extract caffeine from tea is through solid-liquid extraction and followed by liquid-liquid extraction. The reason we use dichloromethane in this experiment is due to the high solubility of caffeine compared to water. Based on the data that we obtained from an article, the mole fraction solubility of caffeine in water at 25 degrees Celsius is 7.916 times 10 to the power of 3, while the solubility of caffeine in dichloromethane at 25 degrees Celsius is 36.961 times 10 to the power of 3. Besides that, dichloromethane also has a higher density than water, hence it will form two distinct layers during the separation process and sinks to the bottom of the separation funnel for easy separation. The function of sodium carbonate in this experiment is to react with tannins in tea to form tannin salt. Tannin salt is an ionic compound that's soluble in water, so that we will not obtain any tannin salt during the recrystallization process. The function of sodium sulfate in this experiment is to remove any excess water from the lower layer which known as extract after the separation process. In the recrystallization process, we heat the extract in a sand bath and let it cool to room temperature when it starts to turn cloudy. In the end, we obtain caffeine crystals in the form of white glycerin needles. From the experiment, we know that the mass of the tea bags are 4.965 grams, while the mass of the caffeine that we obtained at the end of the experiment is 0.141 grams. The percentage yield of caffeine after calculation is 2.84%. The differences between the results of our experiment and also the result of the article is due to the type of tea leaf and also the mass of the tea bags used in both experiments. The Fisher-John melting point apparatus is an apparatus that used to determine the melting point of substances by observing the condition of solid substance as the temperature increases. The melting point of substance is obtained when the substance becomes clear liquid as shown in the picture below. In the experiment, the melting point of caffeine is 250 degrees Celsius, while the data given by the hazardous substances data bank is 236.2 degrees Celsius. This difference in the melting point is due to the presence of the small number of impurities in caffeine that elevated its melting point.
Next is the conclusion. In this experiment, we need to extract water in the tea leaves, and then the caffeine is extracted from the water by using an organic solvent that is insoluble in water, which is dichloromethane. We obtain a total of 0.141 grams of caffeine from 4.965 grams of tea leaves, which is 2.84% yield of caffeine per grams of tea bags. As a conclusion, we were able to extract caffeine from tea leaves using polar-nonpolar solvent extraction techniques. We also managed to determine the melting point of the crystals of caffeine, which is 250 degrees Celsius. And lastly, this is the references that we referred for this experiment. That is all from us. Thank you.